You are standing on a rock. A rock, spinning through the dark, at 67,000 miles an hour. You don't feel it. You never have. Because everything you have ever known, every person you've loved, every war ever fought, every song ever written, every sunrise you've ever watched, happened here. On this one, small, spinning rock, orbiting an ordinary star, in a corner of space so vast that numbers themselves start to lose their meaning. Right now, as you listen to this, you are moving. Not just spinning with the Earth's rotation, but hurtling around the Sun at 67,000 miles an hour. And the Sun itself is moving too, dragging our entire solar system through the galaxy at roughly 500,000 miles an hour, completing one full orbit of the Milky Way center only once every 230 million years. The last time our solar system was in this exact position in its galactic orbit, dinosaurs had not yet appeared on Earth. We don't feel any of it. Not the spin, not the orbit, not the vast, silent journey around the galaxy. We simply live our lives, look up at a sky full of stars, and assume reasonably enough that everything up there is fixed. Permanent. Unmoving. It is, of course, none of those things. Tonight, we're going to leave it all behind. We're going to answer a question so big, it has haunted philosophers, terrified astronomers, and humbled every human being who has ever looked up on a clear night and asked, quietly, to no one in particular, how big is all of this, really? It's a question that sounds simple. A child could ask it. And yet it took our species thousands of years, entire dynasties of civilizations, and some of the sharpest minds ever born just to begin answering it honestly. For most of that history, we got it catastrophically wrong, not out of stupidity, but because the true scale of the universe is so far beyond ordinary human experience that our minds simply were never built to grasp it intuitively. By the end of this hour, you will understand distances so large that light itself, the fastest thing in existence, the very speed limit written into the laws of physics, needs billions of years to cross them. You will understand why the universe might never end, and why that idea is not science fiction, but one of the leading scientific theories we currently have. You will understand why some of the light entering your eyes on a clear night left its source before human beings existed at all. And by the time we're finished, you will understand, more clearly than ever before, just how strange, how rare, and how precious the small blue rock beneath your feet actually is. This is infinite. Every civilization that has ever existed started the same way. Looking up. Wondering what those lights in the sky actually were. For most of human history, we assumed we were the center of everything. The sun, the moon, every star, all of it, we believed, revolved around us. It made sense. It felt true. Stand outside and watch the sky for one night, and it genuinely looks like everything is circling around you. The ancient Greeks built entire mathematical systems to explain it. Medieval astronomers spent lifetimes drawing increasingly complicated diagrams of circles within circles, trying to make the model work, trying to explain why the planets sometimes seem to slow down, stop, and even move backward against the stars. The model never quite worked. Because the model was wrong. It took a Polish astronomer named Nicholas Copernicus, publishing his ideas cautiously, quietly, near the very end of his life in 1543, to finally suggest what now seems obvious, that the sun, not the Earth, sat at the center of our solar system. It took nearly another century, and the invention of the telescope, before an Italian scientist named Galileo Galilei could actually prove it, and he was placed under house arrest by the church for the rest of his life for insisting it was true. We were wrong for thousands of years. And even after we knew better, it took generations more to fully accept it. So let's start with something small enough to actually hold on to, before the scale of this story starts to break your brain a little. Let's start with home. This is Earth. Roughly 8,000 miles across. If you could drive a car around its equator without ever stopping, no traffic, no oceans in the way, it would take you about 9 days. 9 days, to circle the only home our species has ever known, in the entire history of our existence. Every mountain ever climbed, every ocean ever crossed, every border ever drawn and redrawn by war and treaty, all of it fits within those 9 days of driving. Now let's zoom out. Right next to Earth, cosmically speaking, is the moon 238,000 miles away. Every Apollo astronaut who ever walked its surface took about 3 days just to get there. 3 days, and they had already left our planet completely behind, the first human beings in history to see Earth as a whole object, hanging alone in blackness, a fragile blue marble suspended against nothing. Now push further. Past Mars, past the rocky, cratered wasteland where our robots currently wander, searching for the faint chemical echoes of the water that used to flow there billions of years ago. Keep going, out past the asteroid belt, a scattered ring of rocky debris, leftover material that never quite managed to form into a planet, and onward to Jupiter. A planet so enormous, 1,300 Earths could fit inside it, with room left to spare. If Earth were the size of a grape, Jupiter would be the size of a basketball. Its great red spot, a storm larger than our entire planet, has been raging continuously for at least 350 years, possibly far longer. Beyond Jupiter lies Saturn, wrapped in rings made of billions of individual chunks of ice, some no bigger than a grain of sand, others the size of a house. Beyond that, Uranus and Neptune, cold, distant, windswept worlds so far from the sun that sunlight itself takes over 4 hours just to reach them. And then, back near the center of it all, there's the sun. The sun is so large that you could fit 1.3 million Earths inside it and still have space left over. It is, by an enormous margin, the largest and most massive object in our entire solar system. 99.8% of all the mass in our solar system is contained in that one single star. Every planet, every moon, every asteroid, every comet combined, all of it makes up less than 1% of everything orbiting the sun. And yet, and this is the part that starts to matter, the sun is not special. Not even a little. It is one of at least 100 billion stars in our galaxy alone. And it isn't even a particularly large one. There are stars out there so massive that if you replaced our sun with them, their surface would extend past the orbit of Jupiter, swallowing Mercury, Venus, Earth, and Mars whole in the process. Our sun, the star that gives us every harvest, every summer, every single day we've ever lived through, is, in the grand scheme of the galaxy, thoroughly, almost comically average. Let's leave the sun behind for a moment. Let's travel further than any spacecraft humanity has ever built has gone. In 1977, we launched a spacecraft called Voyager 1. Its mission was simple, at least on paper: fly past Jupiter and Saturn, take some photographs, and see what we could learn. Nobody expected it to still be running, still transmitting data back to Earth, nearly 50 years later, powered by a slowly decaying nuclear generator that engineers have carefully rationed, shutting down instrument after instrument, just to keep the spacecraft alive a little longer. Today, Voyager 1 is the most distant human-made object in existence. It is currently flying through interstellar space, over 15 billion miles from home, moving at almost 39,000 miles an hour, faster than any bullet ever fired, faster than any aircraft ever built. And it still has not left home. Not really. Because beyond Neptune, encircling our entire solar system like a shell, lies a vast, mostly empty region called the Oort cloud, a sparse cloud of icy debris left over from the birth of our solar system, believed to stretch out to nearly a light-year from the sun. At Voyager's current speed, scientists estimate it would take another 300 years just to reach the inner edge of that cloud and another 30,000 years after that to fully cross all the way through it. 30,000 years. To leave our own backyard. And once it did, once Voyager finally crossed that boundary, it still wouldn't have reached another star. The nearest star to our sun, a small red dwarf called Proxima Centauri, is 4.2 light-years away. At Voyager's speed, it would take over 70,000 years to get there. Voyager isn't even headed toward it, it's drifting, silently, toward no particular destination at all, carrying a golden record of Earth's sounds and images, in case, someday, something out there finds it. We have sent something to the very edge of what we understand, and it will still be traveling, alone, in the dark, long after every human being alive today, and their children, and their children's children, are gone. And it still won't have reached the front door of the next star over. That is how big our own solar system is. And we haven't even left the driveway yet. It's worth pausing here, just for a moment, on something easy to overlook. Every single spacecraft we have ever launched, every satellite, every probe, every mission that has ever carried human ambition out into the dark, has stayed almost entirely within this same small neighborhood. Only 5 spacecraft in the entire history of our species have ever achieved enough speed to permanently escape our solar system's gravity: Pioneer 10, Pioneer 11, Voyager 1, Voyager 2, and New Horizons. 5. Out of